there's a lot of people that are really, really smart and really, really driven and work really, really hard. And I would just I would love for them to solve some real problems.
Hi and welcome to Heja Framtiden. This episode is in English. Today we're going to meet Anita Schjøll Brede, Norwegian CEO at Iris.ai, basically an AI tool for democratizing science by making academic papers and scientific research more available and accessible. This episode is brought to you in collaboration with Warp Institute and Singularity U Nordic Summit. My name is Christian von Essen, and all information about this podcast is to be found on hejaframtiden.se. Follow us on social media and support us on Patreon if you think that what we do is important. Thank you for listening, and please welcome Anita Schjøll Brede. Welcome to Heja Framtiden, Anita Schjøll Brede.
Thank you.
You are actually Norwegian and you know Swedish.
Yes.
But we'll do this in English anyway because the topics are international and we're in the international context.
Yep.
At Singularity U Nordic Summit.
Yes.
I listened a bit to your presentation earlier. It was very interesting. You talked a lot about AI and how AI needs to meet human understanding.
Yep.
In
Indeed.
order to evolve in a sustainable way.
Mm-hmm.
How did you start? Are you an AI researcher from the beginning?
No, I'm not at all. Actually, so way back when I started out in theater. I was going to be a doctor because I had good grades and all people with good grades went into medical school. I was going to do that. I was just going to do a little bit of theater first. Ended up doing a bachelor's degree in theater. There's no jobs in theater, so I started my first company when I was 20 doing theater stuff. That was our first business plan. And kind of fell in love with the process of starting a company, got frustrated that it wasn't scalable, doing consultancy, and then stumbled headfirst into Silicon Valley in 2009, fell in love with tech and tech startups specifically. Moved to Sweden, where I did a master's in entrepreneurship and business design at Chalmers Entreprenörsskolan at Chalmers. Started a company there, started a company after, and then went to Singularity's Global Solutions Program the summer of 2015. Came there without a company and without really any plans for the rest of my life, and ended up starting what's now called Iris.ai, which is our company. Started that together with a couple of classmates, and that's a little bit more than 3 years ago. And the problem we wanted to solve at Iris required us to build AI. And so that was really kind of, I'd been increasingly technical and increasingly heavy technical, solutions to, in the startups I'd been running the previous few years. And now we were really kind of jumping into the deep end, working with natural language understanding and AI technology.
And you discovered a problem that you wanted to solve.
Yep.
In the scientific research sector. How did you stumble upon that?
So both myself and all of my co-founders, we come at it from different angles. Personally, the company I started at my time at Chalmers, it was a mathematical model for doing energy optimizing of heat exchanger networks in big kind of process industry plants, so paper pulp mills. And it was deeply technical mathematical model. We knew it had come from research somewhere. And we were like, okay, let's just find the researchers. Let's find the right people. Let's find someone to talk to that understands this. And we couldn't. It took us 9 months to find the right person who had written the original research paper, because I didn't know, I sat down in front of Google Scholar and I'm like, thermodynamics, or is it thermal dynamics? That was the level of my knowledge and expertise in this field. But we had clients that wanted to, pay for pilots. We had a software that kind of sort of worked, but we needed more experience, domain expertise. We just couldn't find the people. Turns out the guy lived 3 blocks up at Chalmers, or worked 3 blocks up at Chalmers, and was a Swede. And it took 9 months to find him. And that was my kind of personal frustration. So when we started together with my co-founders, when when they started talking about like their other experiences that was widely different. And, one of my co-founders had health issues about a decade ago that was, he had every incentive in the world to learn about this very, very rare disease that was almost about to kill him. And he couldn't. Because it was so inaccessible. It was so hard to understand. And, so he had that experience. I had this, and we kind of sat down and started ideating and kind of different angles and perspectives, but it was the same core frustration that scientific knowledge is inaccessible, it's hard to understand, and it's hard to kind of gather and make sense of it all. And then we did the kind of regular innovation, like you go out and talk to 100 people that, work in different parts of this industry or in academia and understand like how are they working, what are their biggest frustration, what is most time consuming. And so kind of we mapped out beyond just our own experiences, we mapped out this field.
Because a lot of these academic reports and articles are they locked behind paywalls and
so way too many of them are.
Publishing houses?
Yeah, exactly. So way too many of them are. The good thing is that the open access movement has really gotten some momentum and some traction. And so we are connected. So our tools kind of come connected out of the box with this open access repository collection called Core, operated out of the UK. And they have I think we're up to 135 million open access articles. And so it's a good number. I mean, it's not all of the research in the world. So there's definitely paywalled content as well that is out there and that is not accessible. What we do though is that we sell to big corporates and research institutions and libraries, so like university libraries. And all these institutions are already paying for access to the content they want. And so what we do, and because of the way the technology is built, we can very easily have them make a deal with their content providers that we can connect our tool to that too. Because of the way we do it, that falls very neatly within the terms of service usually.
And what is the AI doing in this particular case?
So it's natural language understanding. And so what it's all about is understanding the context of a piece of text, right? So we, in very short explanation, we take a piece of scientific text. So you write out your own problem statement, or you can use the abstract of a research paper, but a text of 300 to 500 words. Now, the way you do that today is when you have your problem statement, you go build out a massive keyword query, right? So like you're searching for these things and you make some and/or statements of what you're looking for. And that is just taken out of your own head, right? You're just like, based on my experience, here's what I'm looking for. That's fine if you're a deep domain expert and like doing your thing. But the moment you're dealing with more, let's call them unknown unknowns, and you're doing innovation or research in interdisciplinary fields, right? So like material science is a very interdisciplinary field. There's so much out there that might be relevant, but you don't know it because it's not in your domain expertise. So basically what our machine does, it takes an abstract of 300 to 500 words, start by extracting the keywords from the text. Now that's old tech, like a decade old. It's not a big, not a big magical thing. We extract the keywords. Then we use this vectorized model for finding essentially what other words have other researchers used for the same concept. So we find contextual synonyms, and we do that by having the machine read about 18 million research papers. And we do this thing where we show the machine 11 words in a row. We hide the word in the middle, and we tell the machine to guess that word. And you repeat that for every 11-word combination across 18 million articles, and you essentially train that model to spot contextual synonyms. If one author uses car, our system will know that could also be vehicle, right? Same concept. And it will know how close they are. The final, third step is that we do something called topic modeling, where we go, okay, so let's say this text, I'm using simple examples here, let's say this text is about dogs and cats and sheep. Well, what could the topic here be? The topic could be mammals, it could be pets, it could be food, it could be, things that are fluffy. I don't know, it could be a number of things. And so what the machine does is by using clustering algorithms to find what papers are about the similar things, and then we ask the machine, this cluster of papers, how would you describe it in these words? And so we basically find these topic words to describe it. And so we take all of these clusters of words, so the words that are actually in the text, synonyms, and topic words, and we turn that into a fingerprint of the document. And then you can use that fingerprint running some neat algorithms that we've developed to do essentially fingerprint matching with other texts. And you can do that in a really efficient manner, so you can basically match it with thousands and thousands of other texts to find other texts that talk about the same thing, but not necessarily in the same words.
Okay, so for the user, how is this experience different from Google Scholar?
So in Scholar is great when you know what you're looking for, right? You plot in a few words and you find the thing that you're looking for. The difference here is it's much more of a process tool. So it's very specifically for a process where point A, you don't know what you're looking for yet. And point B, you have to get a broad overview. It's not just about finding that one paper. It's about getting an overview of the field. And the process very specifically is you start with a text, 300 to 500 words. You plot that in. Everything I described happens in the course of about 8 to 10 seconds. And then you get this very visual map where we show you here are the main topics, right? So we talk about this topic modeling. We say here are the main topics of your text. Subtopics, and on each subtopic, we're going to show you, anywhere between 1 and 50 research papers on that specific topic in this context. And so in this way, you start exploring quite broadly. And what we see, and we've run it's basically like it's some cool back-end machine learning tech and a nice visual interface that looks very different. And we're like, okay, that's great. We built this thing. What does that mean? And so what we've done is that we've run a number of experiments where we have multiple teams compete to solve the same research challenge in a set number of hours. And then they deliver the results, and some of them use our tool, some of them use Scholar. They deliver the results to a jury that blindly then evaluates them. And what we've found is that this combination of some cool machine learning and this colorful UX and very different visual UX, consistently, like teams that use our tool outperform teams that use Scholar. So it is really, really, really neat. This is the exploration tools. This is very much about, okay, I have this problem. I'm going to branch wildly and see what I can find out there. Now, problem is you're going to end up with say 3,000 papers, or something, maybe 10. So what we launched earlier this year was a tool that then takes those 3,000 papers or whatever, a lot of researchers will have like a Dropbox folder with 10,000 articles they've collected over the course of whenever they got Dropbox. And so what you can do is you can import that corpus, whether it's from your own machine or from all of the maps you just made through the exploration tool. And then we have this tool where we basically focus in on the reading list. And it's the same back-end technology. We show you these topics that I talked about. We show you the concepts, and we ask you what's relevant, what's not relevant. And so rather than you trying to kind of read through, what you do today is that you read through every single title of these 10,000 documents, which is time-consuming. What we instead do is we show you what topics papers fall into, and you're like, this topic is relevant to me, this is not relevant to me. And you do these exclusion-inclusion criteria with manual verification as much as you like, and then you can very easily bring down a reading list of, say, 10,000 papers down to, say a few hundred, or, 500 papers down to just the top 10 that you need.
And you also have a blockchain tool implemented into this, right, where you can actually pay tokens to participants.
So
was that previously?
It's not implemented yet.
Oh, it's not.
We've developed a concept around this. It's called Project Ire, which is, as we talked about initially, this whole, everything is, there's so much content that is paywalled, and it shouldn't be, especially science that has been paid for with tax money. So we launched let's call it a little side project last year, which is Project Ire, which is a blockchain project where the ultimate goal is to open up science so that everyone who contributes to the world of science should be rewarded. That is when you publish, when you peer review, whatever it is, and all science should be open and free. And we developed a really neat business model around it. We put a lot of thought and efforts. Now, sadly, what happened this fall, as we were going to go out and fundraise for this, is that the entire kind of blockchain cryptocurrency market kind of imploded on itself for a bit. So it's been a little bit of a drought the last few months. So the project currently is kind of hanging out until the crypto market ticks up a little bit again and people want to put their money into good projects again. But it is really interesting, the things you can do with blockchain technology. And I think we've developed a really, really interesting model where we can build up an economy around the value of research without having it be a one-to-one relationship between a research paper and, we don't want research to be like patenting things where you own the rights and you can sell those rights, right? Especially so because there's so much fundamental research that isn't directly, commerciable. We don't want, I don't believe that research and, commercial efforts should go too much hand in hand. Obviously, you can have researchers in your team if you need to develop something for commercial purposes, but I think having an academic sector that does academic work and research for the sake of doing it, because it's exciting, because it's fun, because we want to understand, and not having commercial incentives in that. Like, so basically what we've done is build this new business model thinking around it, and basically redesign the incentive structure of academic publishing from the ground up again. And it is a project that needs to be funded to get started, because there's some technology that needs to be built into it when our AI business goes, when we actually start being profitable on that end, or if the cryptocurrency market picks back up, so we can actually do a token sale and generate revenues for it. I'm really sad that that the fundraising round for that wasn't able to be initiated because of the market, because it is a really promising. And it's a potential solution to a problem that is very, very severe.
Yeah, and the overarching goal to decentralize and democratize science and research.
Yep.
What is your aim there? What will happen when that takes place?
So a lot of different things. So first of all, I think the whole paywall concept of scientific research is absolute, it's nonsense and it's crazy, and it stems from a business model that made sense when you had physical papers that actually needed to be physically corrected with pen and ink, and you need to send things around and print it and copy it. And back then it made sense. It doesn't make sense anymore. Elsevier made way much too money last year on a 40% profit margin, which all comes from like academic money, which ultimately comes from taxpayers, right? They charge taxpayers about 4 times over for the same content. It's a great business model. I'm not saying otherwise.
And the universities, they have to buy these books,
right? You have
for lots of money, and no
they
one's
have to.
reading them.
And it's bundled up, right? So you can't just say, oh, we have some archaeologist that wants archaeology magazine #1. Elsevier sells it to them in these bundles, so you have to buy full bundles, and ideally you would have to have everything, but not even Harvard can afford to pay for everything. And then you're like, well, a research paper is only, if you buy it individually, it's only like $20. But fact is, again, because you don't have the right tools to know that that's the paper you need, then like you end up buying a lot of papers and just like skim through them and go, oh, I didn't need that, right? So it's just an unethical business model that I believe is changing, and there's enough incentives going on right now to change it. And so I think we're going to see that, like, when these big publishing houses realize this, like, at some point they're going to, I think they're realizing that it's a losing model. But obviously, when you make a 40% profit margin, you're not going to just change your business model to some with lower profit margin.
Yeah,
that's
I heard a
business,
professor who said that they get approached all the time by these publishing houses to write essays published in these prestigious magazines or books.
Yep.
But no one's reading them, and they're not distributed. They're just sold to the universities, really, really expensive.
And then
they
you
sit
can,
in a library. So.
And as a professor, you can say then, oh, I publish in this magazine, and you put that on your resume. And it's not, I believe thoroughly that it is hampering global progress, and that's a harsh thing to say, but I do believe, and I will say though that I think like that all these publishing houses, and we usually use Elsevier as an example just because they're the biggest ones, but this applies to all of them. Like, I genuinely believe that a lot of people working there have really, really good intentions and really want to see science progress. And I believe that the executive level and the board has a responsibility to realize that they are hampering global progress at the time, and be responsible towards their employees, towards all the brilliant, smart people that are working there, and towards the rest of the world to start changing. We see like signs that they might be, but again, it's too profitable, right? And so maybe ultimately the responsibilities with the shareholders of these big companies that should go and say, you know what, this is enough, right? We don't want to, hamper this. We want to bring all this research out to the world. And if we can do that, like, I genuinely believe that whether we're talking cancer and Alzheimer's or climate change or whatever it is, like, I think we have a lot of answers. If we could, like, if one human being could sit down and read, we don't have the full number, let's say 200 million academic papers that exist. If one human being could just like sit down, read all of it end to end, understand every implication of it, and then kind of just see the patterns of it, I think there's a lot of problems where we go, oh, well, plastic in the oceans, here's the thing with this like chemical compound over here, and this like effect here, and this like sensor here, and this thing here, we could just, and it's not just because there's obviously a lot of development and testing and stuff like that, but I think that there is a lot of solutions in all that knowledge that we humans are just not capable of dealing with. And that's fundamentally what we want to build, a system that can help us do that.
In your talk earlier today, you brought up a few applications where AI can make big change, and you were kind of stressed at the end.
I only got 22 minutes, and I had 15 slides left. It was like,
But can we talk a bit about that? Where do you think AI will be put to best use in the next 5-10 years?
So I think it's one of those things. It's hard to. I'll give a couple of examples, but like I think the first thing that's important to understand is it's already everywhere, right? It's like if you like the example I used in my talk was like when you open your photos on your iPhone and you search, you can do the same in Google Photos as well, and you can put in a keyword, right? And there's a local deep learning algorithm that has recognized every single picture you've ever taken and categorized it. So you can go in and say, show me cat photos, and you'll find all your cat photos, right? Like that is something that like 10 years ago you had to have access to like a supercomputer and like a data set from a university. That wasn't a thing 10 years ago. We had the technology.
I remember Picasso, they wanted you to enter your own keywords.
Right, exactly.
For every photo.
Exactly. And now you don't need to do that anymore, right? And it's automatic. And there's training data sets that have those labels. And we're moving more and more into a world where we don't need those training data sets to the same degree. And so first of all, like AI is already everywhere, and it will continue to be more and more implemented everywhere around us. We just don't think about it as that magical. You just type in cat and you get cat photos. Like what's so dramatic about that? But it's pretty advanced, solid technology. And so it will, like, when we, like, what industries will be affected by AI, like every single one. And I give the example of my dad because I love him very much, and he's one of the smartest people I know. And when I came home from, having attended my summer at Singularity, I told him, that, AI will affect every business. And he's a lawyer, a really good lawyer. And when I told him, he's like, sure, but we're always going to need lawyers. I'm like, that might be true, maybe, unfortunately, not to bash any lawyers, but, having spent some time in the U.S., there's that. But the thing is, like, sure, he's a senior lawyer, runs his own firm as a partner. We're going to need him at least until he retires and beyond, the next, say, 10, 15 years. He might retire before then, but, sure. But then, the thing is that we're going to get a lot of these systems, and there's already this company called Ross that is doing kind of grunt legal work, which is an AI called Ross. And the thing is, like, a lot of the grunt work, which is like, oh, find that, obscure case from, sometime in the 90s in some kind of jurisdiction, like those kinds of like grunt work things, that's going to be all done by machines, because the machines can do it like in a second, while a junior associate might take a day. Right? And it's a lot cheaper and more efficient to do it. And as a company that sells your services, you have a responsibility to your client. And if you want to be competitive, you have a responsibility to not push down prices, but be as effective as you can and efficient as you can. And so a lot of that grunt work can be done with machines. Thus, it will be done by machines because we live in a capitalist structure, which means that all of the junior lawyers won't have work. Right? And so how do you become a senior lawyer if you don't have work as a junior lawyer? And so even if my dad will still have a job for the next, foreseeable future, his company will radically change over the next 10, 15 years because the structure will change. They have to find new ways of teaching their lawyers, which was just used to be used as an example of it is going to be everywhere. And every single job is going to be affected by it in every single area. But then some of the things that I'm really excited about and where we're going to see kind of AI having radical effects on humanity is, for example, disease outbreak predictions. I have some friends that are working on a company called AIME, AIME, and they're working on disease prediction and seeing kind of where, and I think they specifically started with dengue fever, and I don't know if they have other diseases as well right now, where knowing that you are in an area where the dengue fever is not blossoming, but is happening, means you can take really good precautions. But you don't have these good models for predicting until we now actually can use machine learning on vast data sets. And it's not just about like reported outbreaks, but it's also like looking at weather conditions and wind direction and density of population, which you can get from, Google Earth images, et cetera. So like bringing together all these different data sets, you can actually far more accurately than ever start predicting these things. So you can get medication to the right places on the right time. You can alert local population that, hey, there is an outbreak coming, you should, not do these things to prevent that. And with the, abundance of cell phones these days, you can actually get alert systems in place if there's political willingness. So that's like one area where we see a lot of things. Also, more autonomous healthcare in general. There's these microscopes now. The Gates Foundation, I believe, is working on one of these where you can do malaria detection, both to find malaria, to kind of diagnose it, but also follow-up treatment, where you don't actually need anyone to look at the blood samples. There's this microscope that doesn't have the looking part of it. So it's just a microscope where you put in a plate with a blood drop, and the microscope recognizes whether or not there are malaria parasites or what they're called in your blood, which means you don't need a doctor present. You just need someone to put a drop of blood on a piece of glass, which most nurses and other medical personnel can do. Which means you can radically scale up the level of tests you do, which means you can more accurately, again, know how to treat and how people are being treated. So that's also an area, like when we talk about medicine. But then there's also, if we look at kind of personal advice, right? So whether it's, right now everyone's talking about chatbots, right? And you go into a company's page on Facebook and there's a little, automated chat pops up and like you can chat with it. And it's all these little things, right? But like I'm looking forward to a future of like more consolidated personal advice where it's, you don't just ask Siri, hey, when's this bank open? You're like, hey, can I afford to like take my partner out to this really fancy restaurant tonight? And Siri or whatever the chatbot is called will, look at your... It's like, no, not at all, because I know that your car is really old and you're going to need a suspension change soon.
In 2022, you can visit a restaurant.
If you start saving up right now. And like that kind of consolidated advice is also... something that will be really helpful and really useful for a lot of people.
And you also mentioned to build a human understanding into the AI systems when it comes to ethics and so kind of moral aspect of artificial intelligence.
Yep.
How can we make sure that happens?
That's a big question. So I think, there's a lot of ethical discussions going on around AI. There's a lot of discussions that should be had. We'll mention just a couple of things that can go wrong for those of the listeners who haven't fully kind of read up on this yet. I mean, there's, when a human being sits down to program an AI and select a data set, that human being will bring their own biases into that development process. We see a variety of examples of, algorithms being built with, blatant racism embedded in them, not necessarily because the programmer was a direct racist, just, usually a lot of AI programmers are kind of young white males from Palo Alto or around there, and they just don't have the lived experience. So they simply don't stop and think like, hey, if I was a black woman, how would this affect me, right? Which you see also in like imagery, like facial recognition on iPhone. I think it has, for a white young male, like accuracy is like 99%, and for like a black female, it drops to like 60% or 65% or something like that. Which is just because there's not a lot of black females testing the facial recognition, right? And so it's not always like deliberate, but there's all of this bias that we're building into these algorithms. So there's a lot of these ethical discussions, and one of the things that we really have, first of all, we need to talk about it. We need to discuss racial biases, gender biases, all of these biases in algorithms and in human beings, in our own brains. We need to, one of the things that we do, I mean, AI is basically taking historical data and, predicting some kind of future result. The past kind of sucks sometimes. And then the question is like, okay, how do we go about being aware of like what things of the past that we don't want to predict into the future and project into the future. Like, for example, number of female executives or females on boards. If you use algorithms to run job ads, you're not going to find as much women because the algorithm is trained on a data set that has very few women, so they're not going to suggest as many female candidates, et cetera. And so the first thing we need to do is talk about it and be very aware of the things that can go wrong. The second is bringing in more diversity in teams and making sure that you have a variety of lived experience on your team so that when you select a database of, say, models for a, like with Face App, the Face App example where they had a hot filter, you could like put a filter on your selfie, and the hot filter had a database of models that were all white. And so when a black guy, put that filter on his face, made his light, skin lighter and his nose narrower. And it's not that those people sitting and developing it were racist. They just didn't think that through because there were presumably no people of color in the room, right? And it's a very kind of direct implication of just not thinking about it. So we need to think about it. We need to talk about it. And then there's some, challenges that are way, way, way more complex than just being aware as well.
Yeah.
So.
And you mentioned that just because something is statistically correct doesn't mean it's right.
Right, and that's the part.
It's a good
and that's the part about like the past kind of sucking sometimes, right? Is that, it's statistically true that fewer women, have executive roles. That doesn't mean that that's the future we want, but yeah, it's statistically absolutely correct. But we can't base our future prediction algorithms on that because then we're building a future we don't want.
It's like, this postcode usually has a lot of millionaires. Doesn't mean we should direct all our investments or services towards them.
Exactly.
But the algorithm would want to do that. Probably.
Because that's what the data says, right? Yeah. That's where the money is.
Well, we should be summing up. What do you think? Moving forward, what is your best tip to to make a better future? Oh
my, that's a big question. One of my pet peeves, and this goes out to all both big companies, but especially so perhaps startup entrepreneurs, like go out and solve some real problems. Don't invent problems, and especially like if you're. Especially so maybe a challenge to like the young guys in their mid-20s who, there's a lot of people that are really, really smart and really, really driven and work really, really hard. And I would love for them to solve some real problems. Like, don't do more advertising technology. Like, we don't need more shampoo, right? Like, go out there and solve some real problems. Like, it might not get you as rich, but like, I promise it will be so much more rewarding in the long term.
Very good. Thank you, Anita Schjøll Brede.
Thank you.
For visiting Heja Framtiden. And you can find everything you need on hejaframtiden.se. It's mainly in Swedish now, but we'll add some English subpage, I suppose. Thank you for listening. This is from Singularity U Nordic Summit.